Hi, my name is Graham. Welcome to my channel, FlexiTool Guides. Today I'm going to be taking you through the repair of a flat tire on my Janobike X20 scooter. This is a high-performance scooter which is a copy of the X-Tron X20. But the tricks and tips that I'm going to show you can be applied to the repair of virtually any scooter. Please like and subscribe as I will be making more videos in the future. Like many of you, I don't have a specialized workshop with specialized tools. In fact, I'm going to be doing this repair in the hallway of my building, and I'm going to be using everyday items that are commonly available inside of the house to help me. And I'm also going to be using basic tools that will make the job easier and which will save you time and trouble later if you decide to do this on your own scooter. So I have a couple of pieces of old cardboard. There's a mat to protect the butt on that cold stairs. There's an old chair and some tools and a few more items from the house which are going to come in handy. That's a screwdriver, a ratchet, a spanner or a wrench, pliers, electric tape, and a set of Allen keys, a cloth, that's a little dustbin, that's a baking pan, air pump, and gloves. So I was doing some riding up in the mountains on rocky trails, and a day or so later I noticed that my rear tire was flat, and so it needed to be repaired or replaced. The only tools that come with this bike are this specialty tool that I consider to be one of the more clever tools that I've seen, but at the same time it's very difficult to work on the scooter with this tool, and that is why I highly recommend that you buy a separate set of Allen keys. You'll find your life is much easier. So what I've done here is I've taken my chair and I've got my two sets of cardboard, and this is now actually going to become my workbench. And that chair will hold that scooter very comfortably and very stably at exactly the right height for me to be able to work on it just sitting on the stair at the back, which now becomes a sort of work chair for me. And if I need to, I can slide the chair back and forth and pull the scooter closer to me or push it a little bit further away from me. The scooter is extremely heavy, and yours might be too. If you need to, you should ask somebody just to help you lift it to pick it up onto that chair or whatever you are using as your workbench. Now you will notice that I have slid the little dustbin underneath the wheel at the back. So that dustbin is pretty much exactly the height to be able to support my first phase of troubleshooting to try and determine what exactly is causing the leak. Once I know what is causing the leak, I can either repair or I will need to replace my problem. As you can see, that tire is flat. So the first thing I'm going to do here is I'm going to use this baking pan. This baking pan's a common thing in the house, extremely useful. So the way that I'm going to use this baking pan is that I'm going to put a level of water into it which is just sufficient to cover the rim of the wheel, and I'm going to then spin or turn or rotate the wheel so that I can see if there are leaks on the rim itself. The water level in the pan needs to be just high enough to cover where the rim and the tire meet and not be higher than that. I could see that there was no air leaking from the rim itself, but if you look at the valve, right where the valve stem comes out of the tire, you will be able to see I have a constant stream of bubbles. So straight away I know that there is a problem at the valve stem area of the tire. So I'm not sure if this is the valve stem or if it's the tire, but I know that I have my problem area. Now that I know that, I can start to take the wheel apart from the body of the scooter. So the first thing I'm going to need to do is I'm going to need to remove the mud guard or mud flap at the back of the scooter. Notice that I'm using those Allen keys that I bought. Cost me approximately $2. And this is so much easier using a single loose Allen key like this than trying to fiddle with the tool that comes with the scooter. You will notice that I only have 2 of the screws that connect this mud flap onto the chassis of the scooter. And that is because, like a lot of things on these scooters, things are not exact. And so I find it extremely difficult to put 4 on, and I find 2 hold it in place. The upper one on the left and the lower one on the right. Trying to screw all 4 in is just a mission, and I kind of gave up on it, and I find that the 2 hold it without a problem. So as you can see, I've got that off. There's our tire is visible, and I put the screws on the side in a place where I know I'm going to find them, and I'm now ready to continue with the repair. Next, I'm going to remove the wheel nut caps. These wheel nuts are very exposed and very low, so if you're going to go through puddles, mud, etc., there's a very good chance that you will pick up a significant amount of water and dirt on those wheel nuts. So it's good to keep them covered with these wheel nut caps, and you notice I put it on the side, make sure I don't lose those, and that's the best way to make sure that you don't have problems if you need to take your wheels off. My next task is to remove the brake housing. To do this, there are 2 screws. Both of them need to be loosened using the Allen key. Now you can use the tool that came with the bike, but to do this you will find that loose Allen keys are far easier and much more effective to remove these 2 screws. I have found that sophisticated brakes, like hydraulic brakes with ABS on a scooter, have not been as effective as what I would have expected. I've had quite a few problems with the brakes. In particular, they grab. I've had to make a lot of changes and a lot of adjustments to get the brakes working more smoothly. I was also very surprised at how tightly the screws that I have just removed came from the manufacturer. They may be very tight on your scooter. As you can see, I have now got the unit off and I just push it to the back. With the brakes removed, there is nothing holding the wheel onto the chassis except the 2 wheel nuts, and I'm now ready to remove those. There is absolutely no standardization, as far as I can tell, on these scooters with regards to the size of the nuts and screws that are used on these machines. On my particular scooter, the wheel nut size is a 21 metric, and it's actually not a very common wrench size, and many sets will go from 20 to 22, so I actually had to go and buy a separate spanner or wrench to do this job. You might find that this wheel nut is on extremely tightly. This is by design, as there is an enormous amount of force that occurs on these wheels, and so you really need to make sure, even when you put the whole job back together again, you need to make sure they're extremely tight. You may have trouble getting them loose, but they should be tight, and you should persevere if you find that they are very tight. I find with mine that once they are loosened slightly using the wrench, that they will actually come off pretty easily just using your fingers. You can see that my dirt bin support is still underneath the wheel. This is extremely important, as you will see in a moment. Next, I remove the locking washer which sits between the wheel nut and the suspension strut arm. You will recognize this washer because it has a small steel extension which fits into a little groove on the strut arms. Having removed the right hand wheel nut from the wheel stud being the threaded bolt around which the wheel and tire revolve, you will notice that before I go across and show you what's happening on the left side, you'll notice that I secured the wheel stud as I started to loosen the left hand side, because I do not want that right hand side to just drop down. Once the wheel nuts and the locking washers have been removed, the wheel is effectively loose. It's hanging. However, it might not drop because there can be some significant sideways pressure being exerted by the strut arms coming from the chassis. At the same time, it is possible that there is no sideways pressure, and the minute that the wheel is effectively loosened by removing the wheel nut and the lock washers, that the wheel can drop. And the reason why you don't want this wheel to drop is because it's actually still connected to the chassis via the electric cable which comes from the battery to power the motor, and you don't want a hard, heavy drop of the wheel to put strain on that cable, and that dirt bin stops that dropping. Next, you see I remove the spacers, the inner spacers from the wheel stud, and I'll do that on the other side. Notice that there were 3 washers on the right hand side and there are 4 on the left. This is just the way that the scooter came. As I've mentioned, the wheel is still connected to the chassis by the electric power cable to the motor. That is why it's so important to have the support underneath, so that the wheel can rest on something without putting too much stress onto that cable. The reason why I'm able to do this repair without fully removing the wheel is because it has what is known as a split rim. You can see this extra set of screws on the rim of the tire, and what this allows me to do, it allows me to take one side of the rim apart, and so I can then slide the tire off the rim while it is still held in place by that electric cable. Trying to remove these screws using the tool that came with the scooter is extremely difficult because the screws are recessed. So again, I'm going to be using one of my loose Allen keys, which makes the job far, far easier. You might have noticed that I have been working without gloves, and you might have noticed there that I kind of rubbed my thumb and forefinger together. This is a mistake that I have been making since I started this job. The splines on the threaded wheel stud are actually very sharp, and at this particular point in the removal of the tire, I'm going to need to be lifting the tire, grasping the center stud firmly with my fingers, and then rotating the wheel towards me so that I can bring each subsequent screw comfortably towards me for loosening. If I wasn't wearing the gloves, my fingers would be cut more than they already are. And I did actually pick up quite a few cuts, little fine irritating cuts from working with those sharp thread splines in the first place without using the gloves. Right, so for the purposes of speeding up the video, I have speeded up this section of removing these little screws, and you can see that I move very slowly, carefully around the rim and loosen each of them. I generally don't take one out immediately. I normally loosen and keep loosening, so in case there's any tension on any part of the rim, and if you release them all slowly at approximately the same rate, you will not have any problems with screws getting stuck, etc. So once the screws are all loose, what you will find is that as the last screw or last few screws come loose, you will start to see that the hub, the inner part of the wheel with the motor, that will start to come loose, and there you can see that it is now loose. So the tire on the split rim is now ready to be removed. Removal of the tire and its rim are pretty simple. All you do is making sure that you support the motor. You just lift it and you can carefully wriggle the tire on the rim off and out. Now, once you've done that, you notice that I was holding the motor on the center part. That is because I did not want to put any pressure onto the brake disc or the electric cable still connecting the motor to the chassis. And you can see that half of the tire rim remains attached to the wheel. Now that the tire is loose, I can remove the part of the rim that separates with the tire. And this leaves me with the tire that I need to replace or repair. As you can see, you have two separate units. You just need to put the rim on the side and watch where you put those screws, because they are easy to lose. What has really surprised me with this repair or replacement is that I have taken this tire off and it is marked as a tubeless tire, but as you can see, it has a tube in it. I was not expecting to see a tube. Now that I know that there is a tube inside this tire, I'm going to troubleshoot this tube to see if it can be repaired or if it needs to be replaced. The first thing I need to do is remove the tube from inside the tire. This is a relatively straightforward thing to do. You notice I took off the gloves just to make things easier. I'm reasonably careful when I take this out. If the tube is repairable, I want to take it out of the tire in as good shape as possible and not damage it any further. Since I am using only one hand and filming with the other hand, things are a little bit difficult, but normally this would be a very, very quick, very easy job with two hands. The thing to be most careful with here is not to pull on the actual valve. Now that I have the tube free, I can run a very simple test to see exactly where the leak is. And to do this, I'm going to use just a regular basin in my kitchen. As you can see, I've run some water, and what I will do is I will immerse the tube in the water until I find exactly where the bubbles are coming out. Having found only one small hole, I decided I was going to repair the tube rather than replace it. So I have bought a small patch kit which would be used for a bicycle. This is a $2 or €2 purchase, and it is a very cost-effective way to repair the tube. Having first put a layer of adhesive, I then put my patch onto the adhesive, hold it down for a certain amount of time, and my tube is now ready to cure for about a half an hour according to the instructions, but I actually left this tube for about 3 hours to cure. Once I have completed the repair and allowed it to cure, I then take the tube back to my basin of water, test it under water to make sure that it is in fact sealed and that the patch is holding. If I had known that this tire had a tube inside it, I would probably have had a spare on hand and replaced this tube rather than repairing it. So a lesson learned for me is, even if you have a tubeless tire, have a spare tube on hand. This first attempt to put the tube back inside the tire has not been very successful because the tube is overinflated. What I learned here is that you need to deflate that tube so that it's far easier to go inside the tire. Once I had deflated the tube, you can see that it goes in very, very easily, no problems, and even using one hand, I had it inside the tire very quickly. You want to gently push the tube inside the tire without stressing any part of it. It should fit comfortably inside the tire. I can feel with my fingers that there are no kinks and there are no twists. I can now take the tube and the tire back down to the scooter and complete the repair. The basic process, now that I have completed the repair of the tire, is to reverse the steps that I took to take things apart, to put back together. But there are some useful tricks and tips in doing this with the least amount of hassle. While the wheel hub containing the motor is sitting comfortably on its support, what may have happened in this stage is that the two strut arms, which are part of the suspension of the scooter on the main chassis, may have shifted together. If this has happened, especially on a new scooter where everything is very tight, you will struggle to reseat the wheel studs in the strut arm grooves. If this happens, you can create a very small amount of play on the wheel strut arm by loosening one of the top arm nuts. Joining the split part of the rim and the tire together are relatively simple because there is a hole in the rim for the valve. You line up the hole, insert the valve in it, and then drop the split rim down onto the tire, pull the valve out, make sure that it's comfortable and loose, and the tire is ready for reattaching. It can be quite tricky lining up the screw holes with the screws in them on the split rim with the holes on the fixed rim, especially if you are doing this job on your own. In order to align the two parts which are coming together, I'm going to use some electrical tape. This is common and it's found in many homes. I don't have white chalk, for example, which would be another option. I'm going to use this electrical tape to help line up the two sides so that those screw holes match each other. Otherwise, you can spend quite a bit of time trying to match them up, and you have to keep taking the two sides apart, and it's very time consuming. What I'm going to do is I'm going to take a piece of the insulation tape and I'm going to put it so that the center of the piece of tape sits exactly across the center of the hole which I have selected as my fixed guide hole. You can really do this with any kind of tape, or if you do have chalk or some kind of marking pencil at home. The next tip or trick that I'm going to show you involves using a simple shoelace or small piece of cord. Especially if you are working on your own, you will notice that I have tied one side of the tire and the rim together. The reason for doing this is that if you have one hand holding the tire, pushing it on, and one hand holding the motor will often push the split ring out of alignment, and so it's very difficult to achieve alignment without tying one side. I am now going to put a piece of masking tape corresponding to the center of the hole I want to line up with the hole that is already marked on the motor side of the rim. For this, I will again use masking tape. So I should have my 2 pieces of masking tape across the centers of the holes that need to match up, lining up exactly and allowing me to get a good match. And I have controlled the pushing of the split ring off of alignment by using the cord. As I bring the 2 parts together, notice at all times that I am supporting the weight of the motor so that the weight does not hang off that electrical cable that I have mentioned previously. You can see that I have aligned the 2 parts of my tapes and things join together pretty well. I'm able to now support my wheel and tire again using my improvised workbench. I lost a screw there, but that's no problem. And now I should be aligned. You may find that you need to do this a couple of times. It doesn't always align perfectly, but this is part of the job. Even for me, when I did this job, the first couple times I tried it, things didn't line up perfectly. But for the purposes of the video, I have done the filming of one that worked. Probably about my 3rd time I got everything lined up correctly. Now all I need to do is tighten the split rim into the fixed rim part using the screws and of course using my Allen key. If you have problems achieving alignment, you can always take one of the screws out and then with yourself at the same eye level as a screw hole, make the final adjustment so that you align correctly. At this point in time, my shoelace or cord, whatever you're going to use, is still attached, but it needs to come out before you tighten your split rim, as once you tighten the split rim, you will not be able to get that out. So you might need to just use some force if you did it the way I did it. Otherwise, if everything's still loose, it should come out quite easily. I'm now speeding up the installation of the screws. You can see this time I'm wearing the gloves because I don't want any more of those fine thread cuts on my fingers. When one tightens these screws, it is best to work your way from screw to screw around the hub and tighten things methodically, but do not tighten each screw in one go to its absolute max. So what you are doing is you are tensioning the split rim onto the fixed part of the rim in a methodical way, and you will have an even tension and the screws will be torqued down correctly. This is the most efficient and safe way to do this. Right, we are back to normal speed. I'm going to tighten down the last screw and the split rim is securely connected to the fixed rim, and I'm now going to inflate the tire. It's still not inflated. For this, I'm going to use my useful foot pump. This foot pump cost me 15 euros and it's extremely useful. It has a gauge, it shows everything, and I can control the pressure very easily using my foot. So this particular tire is rated for 50 pounds per square inch. I find that as long as I am inflated to between 40 and 50 psi, the scooter handling feels good and the tire looks okay. So here we go. You can see that's almost 40. I'll just give it a couple more pushes and I should be at the 40 that I want to achieve. Right, you can see that that is at 40. Now I release the valve from the pump. I feel it. It's very hard. I can feel it feels good. Don't forget, you need to replace the valve cap, and once that has been secured, the wheel and tire is now ready to be secured back into your two suspension struts. The threaded wheel nuts on which the wheel studs go have been chamfered or beveled so that they have two flat sides which fit up into the rectangular grooves in the suspension struts. After getting the alignment of those rectangular edges correct, it is time to take the internal spacer washers, the ones which go inside the suspension struts. Those go on first. They are keyed with a rectangular hole, so that makes it easy to get them onto the wheel studs. Remember to put the same amount of spacing washers on each side as what were originally on. You may recall, in my case, there were 3 on the right-hand side and there were 4 on the left. Once you have got both sets of washers on, your setup is going to look something like this. The main thing at this stage is that you want to make sure that your horizontal edges on your wheel studs are aligning with the rectangular shape of the holes in the strut arms, as you can see there. If you can get the square edges aligned before you lift the tire and try to insert it into those rectangular tracks, you will save yourself frustration and time and stress on your lower back, as the tolerances are fairly exact and you need to get the angle exact in order for the wheel studs to slot into their tracks. Once you have both sides in their tracks, and you will need for both sides to go in simultaneously, that's how exact the tolerances are. But once they are in, the next thing to check for is to make sure that the wheel stud is completely up to the top of its groove. This is very important. If you don't keep sufficient vertical pressure, the wheel can drop slightly and your alignment can go out, and you can have problems later. Using both hands, one on either side, I firmly bring the wheel studs up into their tracks on the suspension arms. The next part to go on is the lock washer, and the lock washer slots into a small groove, as I have explained previously. Once the lock washer is on, I can then put the lock nut, which actually secures the wheel in its track. This process is then repeated on the other side. Notice that I'm holding the wheel up to make sure that it stays as high up in its track as it can go, and I'm now ready to tighten everything down. I'm going to speed up this section with tightening the wheel lock nuts, but the one thing to really keep in mind when you do this job is to tighten those lock nuts extremely firmly, as they need to be very tight. If you needed to loosen the suspension strut in order to get the wheel back in, now is the time when you need to remember to tighten that nut on the suspension arm. And for this I will be using my ratchet. Like everything on the scooter, everything needs to be tightened down extremely firmly. The scooter undergoes a lot of vibration and rattling, and that is not friendly to screw tightness. And so as a result, you might find that over time screws come loose. I've found that screws have come loose on my scooter. Next, I'm going to be putting the other small pieces that still have to go on. I'm going to be putting those back together and finishing the job off. So this is my disc brakes. The way that disc brake is designed is to give you a little bit of play so that you can seat them correctly. But before I do that, so that I don't forget, what I'm going to do is I'm going to replace the wheel nut caps. So those fit quite tightly. They're designed to prevent dirt and water from getting on those screws and causing a problem. If they don't want to go on normally or easily, then you just tap them a little bit with some kind of a hard object like a screwdriver head or the wrench head, etc. Once those are on, now I'll get back to my brake fitting. Well, I was using the gloves to protect my fingers when working with the wheel studs. You can see here trying to thread the brake housing screws using the gloves wasn't really working for me. The initial part of putting the brake unit back on is quite simple, as you can see. You simply take the unit itself and put it onto the frame, and you will find that those screws will go in quite easily, and in fact they are designed to have some play, as you can see. But before I tighten them, what I'm going to do is I'm just going to reach up to my brake levers on the handlebars, and I'm going to squeeze that a few times. Just squeeze it gently, and then I'm going to squeeze it closed. So 3 or 4 pumps with the brake levers at the handles, and then once it catches on the actual brake disc, then you can see I tighten it up extremely tightly. I'm just going to give the tire and the wheel a couple of hand spins just to make sure that it's spinning freely and there's no obvious problem. Even though I have hand spun the wheel and I don't see any problems, I'm still going to run the motor and spin that wheel under power to just make sure that without any load on it, that there's nothing catching and there's no obvious problems. So there's that's my first spin, and then I'll do it a couple more times just to make sure that things are looking good. There's my second one, and I think I'll just give it one more just to make sure. And there's another one. So at this point, I'm happy to take the scooter out on the road, and I can feel that the tire's still nice and hard, nice and pumped up, and everything running smoothly. I feel pretty good. It's a job well done. As I said at the beginning, I run the mud flap with just 2 screws because these parts are not precision machined. The add-on parts, like for example the mud flaps and other parts on it. This is the last few turns of the screws to put the mud flap on, and when this is done, the job is finished, and hopefully you will have learnt some little tips and tricks on how to do a job like this. not just doing the job correctly, but also using simple tools, and you might have confidence in being able to do this kind of job when you do not have a workshop. And now it's time to get out on the road and give this repair a test. Let's see how it runs. Success! Rides like a dream. If this video was useful to you, please like it and subscribe to the channel, as I will be producing more videos like this in the future. Also, I will be producing some videos of taking the scooter up into some fairly rough country to show just exactly what it can do. Happy riding and have a great day.